To have a short lecture for this video on mutations and a brief view at recombinant DNA methods. Okay, so mutations can occur in different ways. There's different types of mutations. So a mutation simply means a change, and when we say a change in the genetic material, we mean a change that's permanent, that could be passed on to the next generation. Okay, mutations can be caused by all sorts of natural phenomena, and very rarely they can be beneficial. Most of the time, they are harmful. Okay, so a mutagen is an agent that causes a mutation. So that could be a chemical, it could be a sunlight, right? Spontaneous mutations do sometimes happen, and this is in the absence of any actual mutagen. And this you would think about in the way of there's all sorts of molecules going on inside your cell, and occasionally, different things will interact with one another, and in a way that, they're not really supposed to. So it's possible that any number of molecules that come in contact with the DNA sequence could cause something to happen. Molecules are not static, right? They have energy. Even stable molecules and stable atoms are still, right. In a way, you can think of them as being alive, right? They have energy. They have motion. Okay, so spontaneous mutations is not actually as bizarre as it might sound at first until you start thinking on that atomic and molecular level. Okay, so when we're talking about mutations, it's important to think about whether or not they lead to a change in the amino acid sequence. That's when you can start to have actual outcomes, right? Consequences of a mutation. A mutation can be as little as a single base, just one base, and we call that a point mutation. That's the most common. There's pictures in your book of each of these, so please take a look in your book. Missense is that the base substitution, so that single base substitution has resulted in a change in the amino acid. So remember in the last video, towards the end, we saw that amino acid chart where the different codons will code for particular amino acids. So you can see how a single change can sometimes lead to a different amino acid being coded. Nonsense mutation is when the base substitution results not only in a change in the codon, but it's actually now, it's no longer changing it to a different amino acid, it's changing it to a nonsense codon, which would be a stop codon. And so then translation is going to stop at that point, and you won't get to make the rest of that sequence, and so you're not going to have a complete peptide, and it's not going to be made into anything, and so you will not have a functional protein. Now, if it was towards the very end, then there's a possibility of something more interesting happening. If it's in the middle or towards the beginning, then there's no way that anything good is going to come of it. Okay, so another type of mutation, instead of just a single base change, would be looking at adding in or removing completely one or two nucleotides, and that will cause what we call a frame shift. So remember, we think about the sequence as every 3 letters in these codons, right? Well, if you remove 1 or 2 nucleotides and you just remove them, you don't replace them with anything, then your
frameshift mutation is when an insertion or deletion causes a disruption in the reading frame. The reading frame describes how the nucleotides are broken up into sets of codons that are each 3 nucleotides long. Each codon codes for one amino acid in a protein. You can see in the original